Yeah, this is a short, well, it's not going to be that short, it's a video about a dead zone function. Dead zone function is a function that checks an analog input value that it's in the vicinity of 0. It says when it's close to 0, it should be 0. The output from the function should be 0 when it's close to 0. And it could be used, for instance, for a joystick or something that delivers, for instance, a plus minus 20 milliampere input to your controller. And when it's in the mid position, it does not output a 0 value because it's a little off. So it would output a positive value, and something could move around. So we make sure that, okay, if it's in the vicinity of the mid position, it should output 0. So this is a function. It's this one, and here is the function. So it has inputs and parameters, and the x input is the input that we're going to check if it's in the vicinity of 0. This is the maximum positive value. This is a positive value, and the low range is a negative value. And preferably they should be equal on both sides, but they don't have to be that. But the mid value is taken to be 0. So it only works for values that's positive and negative. And the output is just a rescaled output. What's the maximum output or the minimum output? So if the input is 0 to 100, output could be 0 to 50, or rather plus minus 50 and plus minus 100 on the input. And here is the dead zone. So if we say there's a percentage, the dead zone could be a couple of percent, 1% on the positive side and 1% on the negative side. And when we do this rescaling, we say if the scaling can over travel. So let's say if we say we have our input 0 to 100 plus minus 100, if it's 102, should then the output be 52 if the output was plus minus 50. It should be 51 then if we do the scaling correctly. And there's no static here. This is a function, so it's only temporary values. So now we're going to just look at the code. So we just remove the declaration, or we can also move this one on the entire screen. Here are some what it does and so on. But just to explain what it does in some detail, there's a lot of details in the comments which you can read. We transfer the input x to a temporary input because we are going to change it later on down here, as a matter of fact. I have to scroll up. Maybe I could move to the other side here. You should look at the comments here. Well, the output, we assume it is in the dead zone, and the positive value, that's half of the dead zone is on the positive side, half on the negative side, and we just invert the sign here for the negative deadband, this one. We assume it is in the dead zone, and we assume there's no error. And the error here is configuration error. And configuration error is if the positive input is less than 0, it's not positive. And if the dead zone is greater than the dead zone is just the entire range, of course, that's an error. And also if the output, the maximum output is negative, that's an error. Then we just indicate an error here. And then we do the same on the negative side. Let's say if the minimum input is greater than, or the negative input is greater than 0, it's not negative, and so on. And if the negative deadband is less than the minimum value, and if the minimum value here is greater than 0, it's positive. So that's an error. Then we indicate an error. If we do have an error, we just write out 0. There is a fault, and it is in the dead zone, and return is just exit the function. There's no processing. Return means return, exit, done. We are not going to process any more code in this function here. Here we could write 0 and true and true, but they are initialized up here too. So now we have to check this dead zone. Now, when we are down here, there are no parameter errors. It's correctly configure this function when you're using it. And it's the functions. The function has to check the arguments that it get, or the inputs and whatever has to be checked by the function to validate, or else it won't work. So it's a responsibility of the function to check this. Well, okay. What we do now is, scroll a little here, is if the input is outside the dead zone on the positive value, what we do here is that we subtract the dead zone from the input to avoid, so there's this TRX here starts at 0, so we avoid a jump in the output. And then we also have to change the scaling here, or the gradient that we calculate here. Remember that the minimum value is 0, so here is -0 and there is -0. And we subtract the dead zone to just, it's going to be a little steeper than it normally would if it crossed 0. Of course, we could set the dead zone to 0, that would work too. And so this is just linear scaling, so the input could be 0 to 100, or plus minus 100, and the output could be plus minus 50, if we wanted to. And then we do check the negative side. If it was not outside the dead zone on the positive side, check is it outside on the negative side. Remember the if sentence is if it executes this, it's not going to execute this, and not the else either. So if we face the test here, it's going to test this one. Is it outside the dead zone negative side? If it is, it's not in the dead zone, just as up here. And we do the rescaling here to avoid the jump in the output. So the Y output starts at 0. Now, if it's not outside the positive dead zone or outside the negative dead zone, it is in the dead zone. And then we set the output to 0. This is redundant, a redundant test basically, because the Y is set to 0 up here. So we didn't need the else statement, but we have to make sure it should be 0. Okay. And then this is a limitation switch, a parameter limitation. Should we limit the scaling? That is, if the input is greater than 100, if that's what we are using, we should limit it to 50. So if it's 102, it should not be output 51, but still 50. So what we do is, that's limitation, and then we check, is it greater than the maximum output? We set it equal to the maximum output. Is it less than the minimum output? We set it equal to the minimum output. And now here, what we do down here is that we say all these temporaries that we have, we just output the temporaries. So TRY, that's temporary real Y, so it's used for Y. The BC is the dead zone, and TB is temporal Boolean, and the TB is temporal Boolean here. And that's basically what we have. Yes, TR, temporal real, and so on. So this is just a naming convention. We say what type of memory is it? It's temporary memory. And what data type is it? It's a Boolean, it's a real. That's what we are using here, because that's what we are working on. Yeah, so that was a function that we use to check if a value is around 0. And as long as it's around 0, close to 0, it should output 0. And just indicate that it is close to 0. And it also outputs an error. Normally all functions have an output, we call it normally YF, output fault. That if there's something wrong with the function here, there are wrong parameters in the function. It's not configured correctly, which on the parameter inputs, the inputs that start with P. Okay, so that was a quick one on that function.